Hey everybody, this is Larry. This is day 29 of the Leetcode Day Challenge. Hit the like button, hit the subscribe, and join me on Discord, leave a comment, let me know what you think about today's problem. Did we just do this, or I guess they're just doing this very similar problems and I'm like having deja vu. But I want to give a quick intro because apparently I have a lot of new viewers, new subscribers. Thanks for watching. Thanks for Leetcode. I don't know if I'm saying that right because it sounds just like Leetcode, but for kind of featuring me on one of his videos, and I guess that's where people are coming from. Hi everybody. But basically I do a daily problem. I don't think you could see it on the screen, but I have a 1458-day streak, which is actually maybe a little bit embarrassing to even mention it. But basically 4 years of streak because I think I started on April 1st of 2020, during the COVID beginning. Let's not talk about that for today. But basically I would do at least for now, for a long time. We'll see what happens, knock on wood. But I've been doing every problem every day. So if you'd like to do it with me and kind of just like have someone to go do it with, do these daily problems with, well, here I am. And the way that I like to kind of think about these videos is that, well, they're twofold. One is that, you get to see me try to solve it live as much as I can, because I think just judging by the number for this particular one, 2962, it probably is like a contest from like not that long ago. You know what I mean? But that's it. I don't remember this problem because it's all these problems are kind of the same, so it doesn't matter. But yeah, so you kind of get to see me try to attempt to solve it live, or if I already know the answer, then I'll try to explain as much as I can. But what I would like to say is two things, right? One is that these videos should be a companion. These should not replace you trying to code and trying to solve the problem yourself, right? Two is that I say this a lot, and I want to say it again for the people who are new to this video or this channel, is that understanding a problem is not the same as solving a problem. I mean, obviously, you know this when I say it out loud, when I say it to you, but I feel like people are kind of missing or not like really, seizing that idea when they are watching these videos, right? Like, you shouldn't watch these videos passively. These are not for you, like, if you're trying to get an interview, if you're trying to pass an interview, I suppose, they're not testing you to see if you're understanding the problem. They're trying to see if you could solve the problem and implement your understanding on these problems, right? This is different from maybe your college exams or your high school exams or whatever, where you're just like, oh, I know this, I understand this, and I just have to be like, oh, I understand this and I show this, right? So I want you to keep that in mind, and that's why my videos are very different from other people. Is that, well, one is that all the other videos are kind of the same, so that's why I do it this way. Otherwise, what's the difference, right? And then two is that I want you to actively work on these problems with me, or maybe a little bit before, because that's why I don't really like explain all the details sometimes about the problems, because I expect you to have already worked on it really hard, and maybe you get a little stuck. Then you could pause when you need to, as I explain certain kind of almost like a hint, but not really, kind of observations and how I attack these problems, because I'm and I don't always do this 100% correctly. Don't get me wrong. Like, I'm not perfect. No one's perfect. Poor one's perfect. Yeah. And yeah, no one's perfect, and sometimes I miss, sometimes I hit, in terms of the teaching prospects, right? And you learning at home. But I want you to kind of think about that, right? Because the way that I want to explain is not just how to solve, or I don't want to explain the solution, right? You could click on discuss, you can click on solution, and someone, you could read that, right? It's not that, I don't think that would be unique for me. How I try to explain my videos is to explain how I get to the problems, how I step by. Sometimes I skip some steps, and that's my fault, because sometimes I just jump ahead. But I try the best as I can to kind of explain, like, okay, how did I get from point A to point B to point C to point D, which is the completion, right? And yeah, I think that's basically how I structure these, and maybe hopefully this problem is a good problem to kind of demonstrate this. I would say the reason why, and kind of add this on, like, I get a lot of people, after they done Leetcode or competitive programming for a little while, they're stuck at a little point, like maybe it's Q2 or Q, or like, you know, they could solve 2 problems on a contest or 3 problems on a contest, but they can't get the last one. And the reason is because I mean, there are a lot of reasons potentially, but one reason that I think about when I kind of like, you know, go through whatever they've solved is that a lot of problems that they solved, it is true. All you have to do is understand the solution. If you understand the solution, you can solve it, because it is just like, hey, do you know this? And then the answer is yes, and just like, you know, paste it from your mind, right? But as you get to harder problems, it's not about that anymore, or not all the time anyway. I mean, you know, sometimes I guess if you're really good or you memorize a lot of solutions, then, you know, things can happen. But yeah, it's about getting from point A to point B to point C, point D, and then sometimes breaking a problem apart and then putting back together in a cohesive way, right? But yeah, so that's how I really want to structure my videos and stuff. So yeah, so hopefully that makes sense as a context. All right, this is a very long intro. Maybe I need to kind of, you know, one of these days I'll say the same thing, edit it out, and then put it on like a different video. But or just say it again. But let's take a look at today's problem. Hopefully that was kind of, you know, insightful to y'all at home. But okay, today's problem is 2962. Count subarrays where max element appears at least k times. You are given an integer array nums and a positive integer k. Return the number of subarrays where the maximum element of nums appear at least k times in that subarray. A subarray is a contiguous sequence of elements in an array. All right, so basically you're trying to find the number of subarrays where the maximum element, is it maximum or maximum? Okay, yeah, because sometimes people say maximum when they mean maximal, and maximal when they mean maximum, which is a little bit differential. And also sometimes, I don't know, I've seen a lot of dubious problem writing, so I just want to be sure. But this seems pretty reasonable, right? Okay, I mean, is it sliding window? No. But I think one thing that like I said, I want to talk about. I mean, if you watched yesterday's video and maybe the day before's video, in terms of the daily problems, so like a couple of videos ago, I should have kind of maybe explained it a little bit better. But there's this idea of contribution, right? I think in, you know, whether it's sliding window or not, I'm not quite convinced. I mean, it probably is, to be honest, but maybe. I don't. But in any case, whether sliding window or not, we can get to in a second. But I would like to kind of rephrase this problem in terms of what I call contribution, right? Which is that, okay, let's start with this this array. And right now, to be honest, like I know what I mean. I'm just talking about contribution already, right? So I kind of know what the idea would be, or hopefully, or this is one of the ideas that I'm playing with. And I don't know how to, I mean, I don't necessarily know the answer yet, but, you know, we'll try to get to whatever it is. Yeah, in a sec, and then kind of figure it out. But the idea of having contribution is the same thing that we've talked about the last couple of days, which is that, you know, we have a pointer moving from, say, left to right. It doesn't really, I mean, you know, for symmetry reasons, a lot of these things don't matter if it's left to right, right? But for simplicity's sake, we will just say from left to right. And then basically when I say contribution is that for each time it lands at the pointer, it's say, okay, this element, let me write it out. This element is the last element in a subarray. What is the contribution to the answer, right? And I think yesterday was like a max thing, but you know, today you have to do number of subarrays, so it makes more sense as well. Okay, so let's say we start with 1, right? What is the contribution from here? In this case, it's just 0, right? Because there's no array that can end at 0, so we'll just write 0. And we're just kind of doing it in hand. That's the way that I like to kind of think about it is, attacking these problems, and I actually usually maybe today I just for a contest I have it ready, but I have a notebook, and a pencil, and just kind of draw it out. But what I'm drawing out is basically what I'm showing you on screen, just like working a small example, just to kind of see if I could get a feel for things, get a texture for ideas and stuff like that. And sometimes if I'm like really confident, I actually work it out in my head. But for harder problems, I definitely love the notebook and just kind of basically visualizing it, right, in a way that my head can hold. So I have to kind of print the paper so I could see it. But yeah, and then the 3, that's just still 0 because you need how do I say this? Well, I mean, it's still 0 because you need 3, which is the maximum element. To is that the maximum? Is it the maximum? Anyway, yeah, the max element. Just say max. 3, we need to appear twice, so it's still gonna be 0, right? But then now 2 is okay. 2 is still 0, I think, because again, it doesn't have, the suffix right now is 1, 3, 2, and none of them can satisfy, right? So then now this gets interesting. Is 3, the answer is going to be 2, right? Because basically you have 3, 2, 3, and then 3, 2, 3, 1, right? And then now the last answer is 3, and then you can go, well, here is 1, and then everything else after the, I guess before that actually, is a choice. So then you have 1, 2, 3, 4. So then that's 4, right? So already I'm getting some ideas of the texture, which is that, okay, so given this number, if this number is the last element, then we're trying to find the number in which the max element, it's kind of tricky, isn't it? The 10 to the 5th number of numbers. Yeah, so that's basically the idea, right? Is that, okay, given that this is the last element, we're trying to do it. Oops, how did that happen? But yeah, and I have some ideas right now. But basically, if 3 is the maximal element, then what happens? And we're trying to find the time where 3 appears at least twice, and then everything before that is just a choice, right? Because you already satisfy the constraints, and everything is just a choice. What I always call is a degree of freedom, because you have a degree of freedom to choose, however, yeah, in this case, how far you want to extend. In k equals to 2, there's an obvious, like, okay, well, if this is 3 and 3 is the maximum, then you get the next one. Of course, if you have k is equal to 3 or even 4 or something like this, but obviously on a longer array maybe. But then here you have 3 is equal to match this, which is fine. And in that case, maybe there's a sliding window there. But it's not as clear cut to me, right? Because, I mean, okay, here we know that the maximum element is 3. So then here, if you did a sliding window, like, this is left, this is right, on like, k is equal to 3, then you can just, everything to the left and everything to the right is going to be, everything to the left, everything to the right is going to be degrees of freedom, right? Meaning if I had, say, more ones out here, then as long as you have these 3, then everything to the left and everything to the right is a choice. And there are some maths around that, but that's not sufficient, right? Like, there are more arrays. So, you could do sliding windows on the 3s, but you also have to do maybe sliding windows on the 1, for example, because, well, these 3, this is a valid answer, right? Just going from here to here, whatever I highlighted. And of course, 4 of them is also an answer, and this is also an answer, right? So it's a little bit trickier than that. And oh wait, did I misunderstand this? Okay, I think I misunderstood this. I see, okay. Let me double check. Huh. I'm just reread. So sorry about this. I'm rereading this problem again. I mean, I don't think I wasted too much time, but I think I'm rereading this problem. I think I misunderstood this. What I understood was that I thought it meant that the maximal element of the subarray, right? So in that case, if let's just say my subarray is going to be, I don't know, like I said, all the ones. Well, in that case, the maximum element of this subarray is 1, and it appears 3 times. But I think that's not what it's asking, because in that case, it's a much harder problem, and which is why I was like, doesn't make sense. But in this case, then, right? Then now, if we only care about the maximum element, then all the other elements don't even matter. You could just kind of think about them as placeholders, right? And then now you just only have to care about the maximum element, and then we can do sliding window. Yeah, except we have to phrase things a little bit differently again with respect to the contribution, right? So okay, so let's say we only care about the 3. So there's a couple of ways you can do this, but we'll talk about we'll go over the implementation in a second. But yeah, but then here let's just say what did I write here? Okay, so let's say this element is the last element of the maximal element, right? What is the contribution to the answer? Okay. But I think now there is some nuance about this, right? Because you have to think about the degree of freedom. And it's very easy to get wrong, even with the right idea for this one. Because basically, for example, recall that what I said, let's say, k is equal to 3, you have left is equal to right. So then now you have 1 degree of freedom to the left, 1 degree, technically 2, because you have 0 extension and then 1 to the left, right? So, okay, so this is, now let me just write under it, hang on. So this is 2, this is 1, right? So then in the same way, there's 1, 2, 3, 4, 5, 6, right? So that means that the 2 on the left side, 6 on the right side. So that means that there's 12 total degrees of freedom, right? So that means that given this 3 is the last element of the maximal element, there's 12 degrees. But that's not quite the entire picture, right? Because, for example, let's say you have a 3, then what happens? Well, what happens is that you cannot extend, like you cannot extend this to 7, because then here if you include this array, then this is no longer the last element of the maximal element, right? So this can only go extend to 6. I mean, the reason why you need that clarity is because of double counting. Because if you're not careful, you count it this way. Well, here technically this array is this subarray is also this going to be in here, where this is the left and this is the right, right? And here, then now you're going to double count, including this subarray at some point. So, or like, because you're counting all of this, like basically what you're saying is that this is a one subarray. But if you count it on the right, then here, looking through the degree of freedom, oh, I guess the 12 actually goes here. Yeah. 12 choices, right? The 7 is not routed. But yeah, here you have 1 on the right. Should have written it backwards. Yeah. ASCII hard. Oh, it is hard. So you have 4, 3, 2, 1, right? But the problem is here is that if you kind of consider these choices as this one, then now this one will be double counted. So you have to kind of consider the next items and the previous items to cut it off as well. So something like this, and here you actually have to cut it off here so that you don't double count, because then now includes this 3, right? Wait, is that true? No, it's asymmetric to the left to the right. Because there is actually an asymmetry here, because we're thinking about the last element, right? So the first element doesn't count. It's just that because this is still a routed subarray, it's just that we don't want to count it twice. So actually I'm wrong. So this is 3, this is 4. So this means that there's 4 degrees of freedom to the left, 1 degree to the right, and there are 4 choices, right? So yeah, that's actually interesting. And here, now that we worked our case, one idea that I have for you, and this only works if you have a tester, but if you also have your code, you can kind of put this in and test yourself. But yeah, I'm just gonna type this in with some placeholder numbers, and then k is equal to 3, and just return like -1, and then we'll see if this answer should be 16, unless I'm yeah, 16. So okay, so look, I mean that means that my understanding of the problem, or my proposed idea, is right. This is kind of a hard one for a medium one, to be honest. Maybe I'm doing it a funky way, but in any case, at least finally I'm understanding it correctly, because my first reading of the problem was not right, as you saw, and it happens. But okay, so then now that's pretty much the idea, right? So then now the implementation is still not easy. It's a little bit tricky. So I mean, the first thing I'm going to do is just get the maximal element, right? And then maybe, like we said, we only care about the indexes, right? So maybe I have indexes as equal to this, right? So for I index x in nums, or in enumerated nums, so we get the index, then indexes dot append x, or no, we want to append the index if x is equal to the max element, right? So then now we have it in the indexes, and then now it becomes a little bit easier to get the formula, right? Because then now, let's just say for I in range of the length of indexes, and then now or maybe we start from k. Is either k or k minus 1. Let's see, let's say k is 3, then this is going to be 0, 1, 2, so we want k minus 1, right? And the idea is that, okay, the left element is going to be I minus k, and the right is going to be k, whoops, right? So these are the indexes in the indexes, so it should be this, just to be clear, right? So then now the idea here is, just to be kind of maybe continuing the visualization for a second, is that basically what I'm doing is that, okay, given this, I label, I mean, there's the indexes, so there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then now what I'm converting it to is then indexes of 1, 3, 4, 10, right? And then now, of course, if we want to get k times, if it to have k is equal to 3, then it has to contain 3 of these numbers, which from here is just from 0 to k, right? Or 0 to k minus 1, and so forth, right? So that's basically all we have here. Is that right? Am I off by 1? I think I'm off by 1. Whoops. Yeah, sorry. Yeah, because this would have been -1, and in Python is actually like one thing that a little bit pet peeve of mine is that I wish we could turn off negative indexing, because it basically is like a silent error, and then I just messed up and I spent way too long debugging. Okay, so basically I have this. Actually, let me take that and put it up here. Just keeping that idea. But I like to keep the code together, so I just kind of have it here instead. Okay, right? So then now this is the same idea that we have here, right? So the left, the indexes of the left, how do I, okay, so then that means that left is, if the index of left is 1, what does that mean? So if it's 1, we have 2 degrees of freedom, because we could choose from it ending at itself, or 1 to the right, or 1 to the left. So that means that on the left you have left plus 1, and then on, I have to do a total is equal to 0, and then total, we add this times, and then the right side, it's going to be the right, so this is the index, but we actually go right next is equal to indexes of k plus 1, right? Of course, this is a little bit nuanced because k plus 1 can go outside the bounds. You can do 2 things, really. You can maybe add an element n or something like this, or I guess, yeah, you can add an element n to kind of define the last, or you can just add an if statement. For simplicity's sake, I'm just going to add an if statement, but yeah, is less than length of indexes, and we do this, else right next is equal to n, or length of nums, I like n, right? So that is basically like just setting it as a marker of the end, so that we can make our formula easier. And the formula is going to be just like right next minus right, maybe +1. Let's see, right? And for these numbers, to figure out if I'm off by 1 or not, usually I just kind of look at these examples, right? So here, if this is n-1, we want to have 1 degree of freedom. So this is n minus 1, this is going to give me 1, and so that should be right. And that's pretty much it, I think. Hopefully. I mean, unless I misunderstand the problem more. All right, well, a little bit off, but hopefully we can fix it. What am I doing wrong? Okay, now let's debug it quickly. Let's see, make sure that this part is correct, and I'm not missing anything. 1, 3, 4, 10. That's what we expect. Okay, right? So yeah, so total, left, right, and right next. Should be okay. Okay. I have to print a delimiter between problems so that I can see which one is which test case. So okay. That's definitely wrong. So left is going to be 2. Right is 4. Did I mess this up? No. Oh no, I'm looking at the wrong one. Sorry. Okay, so right is 10. Did I mess this up? Oh, I'm dumb. Sorry. This is K, but it should be I, right? And yeah, I'm just using the wrong thing. Okay. Coding geniuses here. Easy to make mistake. All right, there you go. Wow, how did I don't. I mean, been making a lot of silly mistakes lately. But yeah, there you have it. 1459-day streak. And yeah, let's go over the complexity really quickly. I mean, I think this should be, I mean, I didn't make it explicit, and maybe I should have, but I knew it would be fast enough. I mean, so yeah, getting the max is going to be linear time. This is linear time, linear space, right? And then here, indexes can have linear number of items. So yeah, and everything is just O of 1 after this, right? So this is in total linear time, linear space, or O of n time, O of n space. And yeah, and that's all I have for this one. Yeah, and it's in terms of explanation. Hopefully, that was pretty okay. I'm curious how this was only like 3 months ago. I actually don't remember this at all. I'm curious how I did this. Did I do this during a contest? I did not do this during a contest. Maybe I did it in the what day was that? Oh, I was in Taiwan, so I don't know what I guess I did. I probably did this in yeah, I probably did this in a virtual contest, so you could probably find that video. I guess I did it in a more sliding window and less analytical during that problem, but same idea though. But I think, well, the reason I kind of arrived at 2 different problems is, of course, how did I get the degree of freedom where this is the last element. That's pretty good, actually. Basically, I'm summing over. So basically, the idea here is that I'm summing over all the lefts, but in that way, it is doing the multiplication here on the right side without needing to know the next element per se. That's pretty good. I mean, I think the reason why there's, as you can see, the solution kind of diverged in 2 different directions, but it's still the same core idea. And the reason why I kind of went it this way is really because I misunderstood the problem in the beginning, so my head kind of spun a different way. But as you can see, and I don't do this all the time, but it was only 3 months ago, and I came up a different way to kind of approach this, different way of attacking it. And that's the thing, right? Is that maybe, and I didn't do this intentionally, but in the sense that, coming back to the intro, once you actually work on your skill to solve problems and having these ideas and techniques and just playing around with them, the actual implementation, it's it could look really different, but if you have that foundation, you could solve the same problem many different ways. But yeah, that's all I have for this one. Let me know what you think. And yeah, thanks for watching. Stay good, stay healthy, take good mental health. I'll see you out later and take care. Bye bye.